Differentiation Example 5. We're told the temperature, theta degrees Celsius, so this symbol is a Greek letter called theta, measured at a distance of x centimeters from a candle flame, is modeled by this function. And we're told that this is only valid when x is greater than or equal to 1. Remember, x is the distance from the candle flame, and this is only valid for x values greater than or equal to 1. So part 8, find the temperature 4 centimeters from the flame. All this question is asking us to do is find the temperature, which is known as theta in this question, 4 centimeters from the flame when x is 4. That is all they're asking us to do. So when x is 4, theta will equal 16 plus 450 divided by 4 to the power 3 over 2. So this is 16 plus 450 over. So that's going to be the square root of 4 and then cubed. Square root of 4 is 2. 2 cubed is 8. Now 450 divided by 8, top and bottom of that fraction are both even. So I can write down an equivalent fraction to 450 over 8, and that would be 225 over 4. I divide the top and bottom by 2, and that won't change the value of the fraction. I'll have an equivalent fraction there. Now, 16 plus 225 over 4, what I'm going to do now is write them with a common denominator. So 16 is simply 64 over 4. And now they have a common denominator, I can add them together. Just a quick point to make, 64 divided by 4 is 16. You must check that before you go any further, that the fraction you've just written down in place of 16 really does have a value of 16. It must. So common denominator, we're just going to add the numerators. So that's 2, 8, 9 over 4. Now we don't need to turn that into a decimal. We don't need to do anything with it. That will do absolutely fine for an answer. And theta is measured in degrees Celsius, so we could give that as our answer in degrees Celsius. Of course, we can give ourselves some idea of how big this number is, because 280 divided by 4 is 70. So it's actually 72.25 degrees Celsius, but we had no need to turn it into a decimal. Leaving it as a fraction is absolutely fine. Right, B. The important words in B are rate of change. That is telling me we need to find. So if it says find the rate of change, we need to find dy by dx. But in this question, it's not y, it's theta. So we need to find d theta by dx. And again, it's when we are 4 centimeters from the flame. So it's when x is 4. So going back to the original function, I'm going to differentiate this, but problem x is in the denominator. I need to rewrite it before I differentiate. I need to write it with x not in the denominator. So 450 divided by x to the 3 over 2 is the same as 450 multiplied by x to the power minus 3 over 2. Bit of revision there. Think the indices, that's what a negative power means. X to the minus 3 over 2 means 1 over x to the 3 over 2. And that's what we had there, but of course with the extra 450. Now it's ready to differentiate. Let's differentiate. The first term is a constant. Differentiate it, it disappears. So let's move on to the second term. Multiply by the power. So it's going to be 450 times by minus 3 over 2. So I've multiplied by the power of x. Now we're going to take away 1 from the power of x. That's what we get. Let's just simplify this first term here. Well, I've got a positive number times a negative number, so it's negative. I need to times by 3 and divide by 2. I'm going to choose to divide by 2 first, and then times by 3. So 450 divided by 2 is 225, times it by 3, 675. X to the power minus 5 over 2. That's now fully simplified. So let's sub in x is 4 now. So when x is 4, the rate of change of the temperature, in other words, d theta by dx, is going to equal minus 675 times 4, and the power of 4 is minus 5 over 2. Let's remind ourselves what negative power means. It means 4 must go in the denominator here, and the bottom number in the power is the root, so that's square root of 4, and the top number is the power. So we need to be doing the square root of 4, which is 2, and then raise it to the power 5. So 2 times 2 times 2 times 2 times 2, that's 2 to the power 5, which is 2 times 2 is 4, times 2 is 8, times 2 is 16, so 32 in the denominator. So it's minus 675 over 32. And that is the rate of change of the temperature when x is 4.